Hello and welcome. Today we'll be talking about the process of deploying autonomous vehicles for mail delivery and how a group of students went from this to this. My name is David Paz, and this has been the focus of my research for the past 2 years. This work actually originates at UCSD's Autonomous Vehicle Lab, which is located in the San Diego area, or as we like to call it, Robot Beach. Therefore, the name for this channel. This autonomous vehicle project specifically is led by Dr. Henrik Christensen and Dr. Todd Hilton. It is very important to note that without their support, this project would not be possible. This all started April 6, 2018, exactly 2 years ago, when we took delivery of two 6-seater golf carts. These carts are not exactly what you would call ordinary. They have been retrofitted with a drive-by-wire system that provides an interface for controlling the steering wheel, the accelerator, as well as the brake pedals. Yes, you can basically drive these cars with a joystick controller, but in addition to that, they're equipped with a different number of other sensors such as LiDARs, cameras, ultrasonic sensors, inertial measurement units, as well as GPS antennas. In the early days, we experimented with open source packages based on the Robot Operating System, or otherwise known as ROS. We also implemented our own software packages with the goal of eventually delivering mail autonomously. But to better understand the overall architecture, it's worth looking at the different components, which consist of localization, perception, planning, and control. At the top of the stack, we have localization, which is essentially the process of estimating the vehicle pose over time. This is performed with respect to an arbitrary frame of reference, which consists of position and orientation. We have experimented with LiDAR-driven methodologies, as seen here, but our main focus is primarily on vision-oriented techniques that require LiDAR map representations of our environment. The next part of the architecture involves perception, which is really the ability to perceive what's happening around the car at all times, to make better predictions based on fused information, and determine simple questions like, is a pedestrian going to cross or stop at the intersection? Some techniques involve computer vision and deep learning, others traditional detection algorithms that use depth estimation, but also robust sensor fusion. We also love the idea of leveraging radar technologies along with vision-driven methods. Once the complete picture around the vehicle has been constructed, we combine the notion of where we think we are, which we can obtain from localization, and then plan our next set of actions while considering the obstacles around us. We also consider the destination as well as traffic rules, such as making full stops at intersections, obeying speed limits, or simply following vehicles ahead of us. Finally, with the short-term plans in place, which we can define by trajectories during the planning stage, it then becomes relatively straightforward to estimate what are the appropriate steering control inputs, like linear and angular velocities, but also acceleration and braking. We've experimented with simple kinematics models that can model the vehicle dynamics, such as the Ackermann model, but also something very simple as the bicycle model. With this pipeline in place, what better way to put it to the test than placing large boxes in front of the cars? We eventually ran out of large boxes, and we brought the vehicles back to campus, where we actually improved the overall control strategies, as shown here. While the results were very exciting, we also worked on figuring out how to navigate through stop sign protected intersections, how to do better obstacle detection, and also understanding the ever so challenging problem of predicting human behavior, like trying to understand what other UCSD students and drivers are thinking. This process actually took a considerable amount of time, especially since a lot of students working on this project are full-time students. But finally, in the summer of 2019, we put together a collaboration with the UCSD Mailing Center. We took a full row of seats out of the vehicles, and we started delivering mail to 2 undergraduate colleges. So if you're a UCSD student in Warren or 6 College, it's very likely that we might have delivered some of your Amazon packages at some point. Anyway, to say the least, we've had great experiences. I've had a great time working with a lot of my teammates. Very interesting takeaways on things we thought that were going to work but didn't work, and things that we thought weren't going to work but actually worked. Some drivers didn't particularly like the way we made full stops at intersections, but that's simply what the law requires. This project is actually still a very active area of research, which is rapidly evolving over the past several months. So while we work from home and plan the next release, the cars are taking a break in storage at the moment. And this essentially covers the story behind UCSD Autonomous Vehicle Project for mail delivery. There are a lot of details that would take more than just a video to cover, so it might be good to put together a sequence of videos to describe what were some of the challenges about the technology, but also what are some of the common problems that self-driving cars are experiencing, to try to answer the question, why aren't autonomous vehicles everywhere yet? That is all. Here's a video of our first autonomous mail delivery trip. A real time video will be listed in the description below. Stay safe. I'll see you in the next one.